One of the most underestimated challenges in machine learning is the gap between training a model and serving it in production. So many models perform brilliantly during the training phase, only to stumble and fail once they're deployed into the real world. And it's usually not because the model is bad. It's because the world of training and the world of serving are fundamentally different. Let's break it down. Training typically happens offline. You're working with historical data, nice, clean, complete, and carefully curated dataset. You have the luxury of time. If an experiment doesn't work out, no problem. You just retrain, tweak your parameters, and try again. It's a controlled, predictable environment. Now, contrast that with serving. Serving is live. It's real time. Data is flying in as we speak, and it's often a mess. You'll have missing values, delayed information, noisy inputs, or data that looks nothing like what you trained on. And on top of all that, your predictions need to be lightning fast, incredibly reliable, and consistent, all while staying within strict latency and budget limits. It's a high-pressure, chaotic environment. This huge difference creates a classic failure pattern. The features you use to train your model simply aren't available at serving time, or, even more subtly, they're calculated in a slightly different way. So, your model learned about one version of reality during training, but it's facing a completely different one during deployment. This problem has a name: training-serving skew. The model itself is the same, but the data it's seeing has changed dramatically, and as a result, its performance plummets. Even though your training metrics looked absolutely stellar, you thought you had an A+ model. But in the real world, it's failing the test. Another major hurdle is scale. You might train your model once a day or even once a week, but in serving, you could be hit with thousands or even millions of prediction requests every single second. A model that trained just fine on your powerful machine might be far too slow, too expensive, or too unstable to handle that kind of production load. This is exactly why modern machine learning systems have to be designed end-to-end. You can't just build a model in a silo and hope for the best. You have to architect the entire system: the data pipelines, the feature engineering logic, the infrastructure, and the monitoring, with both training and serving in mind from day one. They have to work together seamlessly. The best ML systems are obsessed with closing this gap. They reuse the exact same code for feature calculation in both training and serving. They rigorously validate data at every single stage. They stress test their models under conditions that mimic the chaos of production, long before they ever see a real user. Grasping this distinction completely changes how you approach machine learning. Success isn't just about hitting 99% accuracy in your training notebook. The real measure of success is whether your model performs reliably and predictably when it's out in the wild, interacting with real users and messy, real-world data. This is why so many machine learning failures are invisible in a Jupyter notebook. They only rear their ugly heads after deployment, when the stakes are highest. At the end of the day, production machine learning isn't about building the most sophisticated training setup. It's about engineering robust, resilient systems that can survive and thrive during that critical transition from the lab to the real world. Thanks for watching. And if you found this helpful, be sure to like and subscribe for more content.